Okay, so we're moving on now to plane geometry. The last couple of weeks we've been doing exponentials and logarithms, and those are new topics in A-level maths, but plane geometry is something you're quite familiar with from GCSE maths. So what we're doing here at A-level maths is we're going to tighten up your methods a little bit, maybe speed them up a little bit, and the reason is because the questions we're going to get at the end are going to be more involved, and so therefore the methods that we use to do the routine things need to be quick, secure, you can't make a mistake doing them, and they need to be efficient. Okay, so let's get cracking. So as I said, the first bit of the lesson is just going to be straightforward stuff. It's just going to be the mechanism for how we do things. Okay, so parallel and perpendicular lines. First thing we want to do is we want to find the length of a line connecting these 2 points. So we've got 2 points here, A and B, and this is the method that we're going to use. We're going to write the coordinates of the points one underneath each other. It doesn't matter which order, so B is 3, 6, and A is 1, 2, and then it says subtract them, so we're going to subtract them. Then it says subtract them, so we're going to subtract them, so that gives us 4 and 2. And then the next thing it says is square them, so we're going to square them, so square them. And now it says just add, and so we're going to add them, and then that will be equal to the length of AB squared, so that's equal to the length of AB. So this modulus of AB, these two lines are modulus of AB, means the length of AB. And so that gives us 4 squared is 16 plus 4 is 20, and then square rooting both sides, length of AB is 2 root 5, doing the third. Okay, we don't need plus or minus because it's a length, so we're not really interested in calling it a negative number. So similar question, using exactly the same method. Let's write them one underneath each other. S is 12 minus 1, R is 7, 11, and we are going to subtract them. So minus 1 subtract 11 is minus 12. 12 subtract 7 is 5. We're going to square them. We're going to square them. Let's just put a bracket around that and square it. Then we're going to add them, and then that's going to equal to the length of RS squared. So the length of RS squared is going to be 25, add 144 is 169, and so the length of RS is going to be 13. Okay, quick, efficient, fault-free method. Okay, now we're trying to find the midpoint. So we're trying to find the midpoint. So we're going to write the coordinates one underneath the other like we did last time. So start off with B is 3, 6, and A is 1, 2. Again, it doesn't matter which one you put at the top, which one you put at the bottom. This time we're going to add them. So this time we're going to add them. So that's going to give us 8 and 4, but we're going to divide by 2. Divide by 2, divide by 2, and call that the midpoint. And so the midpoint is 2, 4. Same thing again. S is 12, minus 1. R is 7, 11. We're going to add them. And so that's going to give us 10. And we're going to add those together. And so that's going to give us 19. And we're going to divide by 2. And then that's going to be called our midpoint. And so our midpoint, you could say, you could leave that as 19 over 2, or you can write it as 9.5, 5. The method will work if you know the midpoint and you want to find one of the endpoints. So if they give you the midpoint, we can still use the same method. So that's what's happened in this question. What we've got is we've got a line, and they've told us the two endpoints. No, sorry, they've told us one of the endpoints. They've told us L is 4, minus 2. The other one is N. n, and they haven't told us that. I'm just going to call it x comma y because they haven't told us what the coordinates are. But they do tell us the midpoint is 7 comma 1. So we can still use the same method here. So call the unknown endpoint xy. I've already done that. Write the coordinates one underneath each other. Okay. So n is x comma y and L is 4 comma minus 2. Find the midpoint just as normal. So add them together. Add them together. So that's y add negative 2, y minus 2, and x plus 4, and divide by 2, and divide by 2. And there's our midpoint. Find the midpoint. Okay. And then compare this with the actual midpoint. So now they're saying, yeah, but you know the actual midpoint. You know the actual midpoint here. So just compare it. The actual midpoint is 7 comma 1. And so that means that this has got to match this, which tells me that x plus 4 over 2 has got to be 7. So x plus 4 has got to be 14. So x has got to be 10. And the y coordinates have got to match as well. And so we can make those equal to each other. Y minus 2 over 2 equals 1. Y minus 2 equals 2. Y equals 4. So n is 10 comma 4. Okay. So we used the same method. We didn't know one of the endpoints, so we called it x comma y. I don't think that's my favoured method for doing this question. I think I would prefer to do it using vectors. So I would look at this vector here. Whoops. I would look at this vector here, from here to here, and the vector is how much do you go along the x-axis? So from 4 to 7 you go 3 along the x-axis, and then how much do you go along the y-axis? From minus 2 to 1 you go 3 along the y-axis. So now this vector here has got to be the same as this vector here. They've got to be the same vector. And so now I can say, right, I'm starting from 7 along the x-axis, then I'm moving 3 more. So 7 plus 3 would be 10. And then I'm starting from 1 on the y-axis, and I'm moving 3 more. 1 plus 3 would be 4. So 10 comma 4, same answer as we got here. I prefer using vectors. You choose your method. Okay, now it's asking us to find the gradient of a line connecting 2 points. So again, we have an efficient method for that. Write the coordinates one underneath each other, same as we did last time. So B is 3 comma 6, A is 1 comma 2. Subtract them. Yeah, we did subtract them when we were doing the length. So subtract them. So that gives us 4, and that gives us 2. And then reverse divide. What does reverse divide mean? Well, normal divide is when you do 4 over 7, and that's called a forward slash. Reverse divide is a backslash. And so there's our gradient, equals 4 over 2, which is 2. Okay, let's do another one. So our points are S as 12 comma minus 1, and R is 7 comma 11. We're going to subtract them, and so that's going to give us minus 1 subtract 11 is minus 12, and subtract those two is going to be 12 subtract 7 is 5, and then we're going to reverse divide. Reverse divide is our gradient, which is minus 12 over 5, which is minus 2.4. Okay, this is an equation of a line, and we want to find the gradient from the equation. And so it's saying, okay, well, you need to then make y the subject. It's got to be written in the form y equals mx plus c, and then it will be easy for you to find the gradient. So let's do that. Let's rewrite it in the form y equals mx plus c. So let's move the 2x across. 6y equals 24 minus 2x, and let's divide by 6. And so that gives us y equals 4 minus a third x. The number next to the x is the gradient. So the minus a third is the gradient, and then the 4 is the y-intercept. Okay, so there's our gradient, is minus a third. Okay, same thing. We're going to have to make y the subject. So let's do the same thing as we did last time. Let's move this x over 3 across, minus x over 3, minus x over 3. That's going to cancel with that. And so it's giving us y over 4 equals 1 minus x over 3. And then let's times it by 4. And so that gives us y equals 4 minus 4x over 3. And so here's our gradient. And here's our y-intercept. Which lines are parallel? So parallel lines have the same gradient. So using the same method as before, we can easily find these gradients. So I'm just going to do them in my head. So the gradient here is going to be minus 2 over 3. That's just in the form y equals mx plus c. The gradient here is going to be 2 over 3. And the gradient here is going to be minus 2 over 3. And then the gradient here is going to be 3 over 2. And then the gradient here is going to be minus 3 over 2. So we're looking for the parallel lines. They'll have the same gradient. And so these two have the same gradient. So these two are parallel. These two are parallel lines. Those two are parallel to each other. Which lines are perpendicular? Perpendicular lines have gradients that multiply to give minus 1. So if you take two perpendicular lines and you multiply their gradients, it'll give you minus 1. But there's a different way of saying the same thing. A different way of saying the same thing is if you have a gradient of your line, yeah, let's say the gradient of your line is 3 over 5. If you then change the sign, changing the sign would make it minus 3 over 5. And then you recip that would make it minus 5 over 3. That will be the perpendicular gradient. So if you want to go from a gradient to the perpendicular gradient, you change the sign and recip. Sometimes we say that more quickly as the negative reciprocal. So if I go back to these and I look at this gradient here, the negative reciprocal of that would be 3 over 2. And here we go, 3 over 2. So these two lines are perpendicular to each other. These two lines are perpendicular to each other. But remember, this one was parallel to this one. The green ones were parallel to each other. So then this is also going to be perpendicular to that one. Okay. Let's look at this one. 2/3. The negative reciprocal will be minus 3 over 2. Ah, yes, minus 3 over 2. So this one is perpendicular. This one is perpendicular to this one. Those are perpendicular to each other. Okay. What's the gradient of a line that's perpendicular to 2x plus 6y equals 24? Well, we've had this equation before and we had to make y the subject of it before, and we already saw that y equals 4 minus a third x. So we know this line has a gradient of minus a third. We just did that a little while ago. Right, so we know this line has a gradient of minus a third. So if we change the sign plus a third and reciprocal 3, then that will be the perpendicular gradient. So what's the gradient of a line perpendicular to this? The perpendicular line would have a gradient of 3. What's the angle of this line? So that's the same line as before, which we saw had a gradient of minus a third. How do you find the angle of the line? Well, you take the gradient, which we know is minus a third, and you inverse tan it. On the calculator, you do the inverse tan of that. So hold on, let me get the calculator. Bear with. Okay, done it. Minus 18.4 degrees roughly. Minus 18.4 degrees. That's the angle of the line. But what do we mean by that's the angle of the line? So let's just explain that a little bit. So let's just put a little grid up. And on the grid, I'm just going to move my grid across a bit. On my grid, let's draw this line. We already know it's y equals 4 minus a third x. So the y-intercept is 4. So we're going to start from 4 on the y-axis. So 1, 2, 3, 4. And the gradient is minus a third. The gradient is minus a third. When I see the gradient is minus a third, next to it I write up and across. And then I start from the y-intercept. And I go minus 1 up, 1, 2, 3 across. And then just connect those 2 points with a straight line. Just connect those 2 points with a straight line. And so, oh, I missed. And so there's my line. I'm just going to try and extend this line a little bit. Why won't it let me extend it? There we go. Okay, and extend this line a little bit. Okay. So in A-level maths, we measure angles from the positive x-axis, so from this positive x-axis here, and we measure them anti-clockwise. We don't use bearings at all. Bearings are from the north and clockwise. No, not in A-level maths. From the x-axis and anti-clockwise. So a positive angle would go that way. Ours is negative 18.4, and yeah, of course, negative means it goes down this way. So it's 18.4 degrees down that way. Okay, so remember that. Angles in A-level maths are from the positive x-axis and measured anti-clockwise. Altitudes and medians. So the altitude through A, obviously, it has to go through A. So the altitude through A is going to go through A. It's going to go through A. Whoops. Try that again. It's going to go through A. And then it's going to be perpendicular to the other side. So it's going to be perpendicular to the other side. You can draw it longer. That's fine. So there's my altitude through A. The median through A is going to go through A again, but it's going to go through the midpoint of the opposite side. So the median through A is going to go through A, and then it's going to go through the middle of this side. So that's going to come through the middle here, M. Okay, so that's what we mean by a median. Now, these are going to be useful to us. The median is going to be useful to us much later on when we want to find the center of mass of a triangular lamina, like this might be. It might be made out of a sheet of metal, and we want to know where the center of mass is. Center of mass is where you'd pivot it from. The center of mass would be 1/3 of the way up. So if I just divide that into thirds, it would be 1/3 of the way up. So say here would be the center of mass, the pivot point, 1/3 of the way up the median. Now, actually, you don't have to go 1/3 of the way up the median. You could instead do another median from B. So the median through B would start through B, and then it will go through the middle of AC. And you can see that the medians meet at the center of mass. Okay, so, all right. What about the altitude? The altitude is going to be useful to us when we want to find the height of the triangle. And so if we want to find the area, we might want to do half base times perpendicular height. This would be the perpendicular height. So that's one thing we might use the altitude for. And again, if you were to draw the altitude through C and the altitude through B, then you'd find those three all meet in one point. and that point's called the orthocenter of the triangle, and we'll learn later on what that's about and what that's useful for. Okay, we move on now, finding the equation of a line, and we start with the easiest situation. If you have a vertical line like this, then the equation will just be x equals something. In this case, x equals 6, so x equals 6. If you have a horizontal line, it will just be y equals something. In this case, y equals 6. So this vertical line will be x is minus 4. Okay, that's the easiest situation. The next easiest situation is if they give you the gradient and the y-intercept. Well, that's just, you just fill them into y equals mx plus c. You know y equals mx plus c from GCSE maths. M, the number in front of the x, is the gradient. We call it m. And the number that's on its own is the y-intercept, where it hits the y-axis. So if I look at this question, I can see that they've given me the gradient. And maybe if I look closely, I'll realize that this is the y-intercept. How come? Well, it tells us, whoops, try that again. It tells us that the line has gradient minus half through 0,2. So 0,2 would be this point here, 0, 1, 2. 0,2 would be that point there. So 0,2 is obviously on the y-axis, so it's the y-intercept. The gradient is minus 1 up, 2 across, and so the line kind of looks like this. The line kind of looks like that. So there's our line. And they're saying find the equation of it, but it's easy. You just fill the gradient and the y-intercept into y equals mx plus c. Y equals m x plus c. Really simple. That's not going to happen in A-level maths. More likely, you'll be given the gradient and one other point. So if you're given the gradient and one other point, then in A-level maths we use it. If we don't use y equals mx plus c, it's going to cause us problems later on if we do that, because when we come to parametric equations and we want to find the general normal or the general tangent, it's going to make a mess, whereas this method won't make a mess. Okay, so y minus y1 equals mx minus x1. So m is the gradient. M is the gradient. So in this case, my gradient is 2, and so that's my m. And x1 and y1 are the point that you know. So x1 and y1 are the point that you know. So x1 is 2 is my x1, and my y1 is 6 is my y1. Okay, so let's fill them in. So y minus y1 is 6 equals my gradient is 2, x minus my x1 is 2. And then let's multiply it out. Y minus 6 equals 2x minus 4. And in A-level maths, we don't tend to write it as y equals 2x plus 2. I mean, you can do. We mostly tend to write it in the form ax plus by equals c. So x's and y's on one side, numbers on the other side. And we don't want any fractions, so a and b would not be fractions. A and b and c would not be fractions. We would multiply through by denominators if we did have fractions. So I'm going to rewrite this as 2x minus y equals minus 2. So there's my equation, my line. Ax plus by equals c. Okay, same thing. This is my x1. This is my y1. This is my gradient. So I just do y minus y1 minus minus 1 equals m minus 2. X minus my x1 is 2. Multiply it out, y plus 1 equals 4 minus 2x, and then 2x plus y equals 5. That's the most usual situation. In fact, I'm going to say whenever we're trying to do a more convoluted question and we've got a line on our diagram, I'd ask you, do you know a point on that line? Do you know the gradient? If you do, you can find its equation. But if you're given 2 points, then, well, you can just go back to what we learned before, which is if you're given 2 points and you want to find the gradient connecting them, you can just subtract and reverse divide. and then you'll know the gradient, and then you can revert back to this equation. Y minus y1 equals mx minus x1. Okay, so here we're given 2 points. So first thing to do is let's find the gradient connecting them. So b is minus 2 comma 3, a is 1 comma 0. We have to subtract. So 3 subtract 0 is 3, minus 2 subtract 1 is minus 3, and then we have to reverse divide, and then that gives us the gradient. So the gradient is minus 1. And then we can use either one of these points. We don't need to use them both, so we can just sort of scratch out one of the points. We don't need them both. We can just use one of the points. And then we can say, okay, y minus y1 equals mx minus x1. So y minus 0 equals gradient minus 1, x minus x1 is 1. So y equals 1 minus x, or x plus y equals 1. Find the equation of the line through C and D. So it's the same thing again. We're just going to find the gradient. So D is 2 comma 6, C is 0 comma 2. We're going to subtract them, so that's going to be 4, that's going to be 2. We're going to reverse divide, that's going to be our gradient, which is 2. Then we're going to scratch out one of the points, we don't need them both anymore, and then that's going to be our x1, that's going to be our y1, and then we're going to do y minus y1 equals m2 x minus our x1 is 0. And so that just gives us y minus 2 equals 2x, and then 2x minus 2x minus y equals minus 2. Okay, so those are all the different situations where we'd need to find the equation of a line. Now we're moving on to mensuration, finding where a line hits the axes. So you already know this from GCSE. The y-intercept is where a line meets the y-axis, and to find the y-intercept, you put in x is 0. Now this form of an equation is called the two-intercept form because it's actually tremendously easy to find where it hits the x-axis and hits the y-axis. So for instance, if I want to put in x is 0 to find the y-intercept, that's just going to make this whole thing 0. So that's just going to become 0. So that's going to just become 0. And so the y-intercept is 4. Y-intercept is 4. Just that number there. Okay. What if I want to find the root? The root is where it hits the x-axis. You put in y is 0. If I want to put in y is 0 into here, that's just going to become 0. And so the root is going to be x is 3. So you can see why it's called the two-intercept form. So now I know that if I wanted to sketch this line, I would say, oh, okay, I know it hits the x-axis at 3, 1, 2, 3. It hits the y-axis at 4, 1, 2, 3, 4. And then I would just connect them together using a straight line. And so there's my line connecting those 2 points. That's the line x over 3 plus y over 4 equals 1. Find where the line through 4, 2 and 6, 4 crosses the x-axis. So we're trying to find the root where it crosses the x-axis, but this time we don't know the equation. So they just made it a little bit longer for us. We have to find the equation first. So let's call the points A and B. So B can be 6, 4 and A can be 4, 2. And then we can find the gradient by subtracting. So that's going to be 2 and that's going to be 2, and then reverse divide. And so the gradient is going to be 1. And then we can just use one of the points. Y minus 2 equals 1, x minus 4. And so y minus 2 equals x minus 4. And add the 4 to both sides. So 2 equals x minus y. And then I want to find where it crosses the x-axis. So just put in y is 0. If you put in y is 0, that's just when it becomes 0. And so it's going to be x is 2. So it crosses the x-axis at x is 2. Its root is at x is 2. Okay. Sketching a line. So if we have a line in this form, in the form y equals mx plus c, we can identify the y-intercept and start from that point. So in this case, my y-intercept is going to be minus 6. It's the number that's on its own. So the y-intercept is going to be minus 6. So just put a blob here at minus 6. And write the gradient as a fraction. So here's my gradient. And it's 2 over 3. So write it as a fraction. So the gradient is 2 over 3. And then just put up and across. Up and across. And then start from the y-intercept. But now do what the gradient says. Go 2 up and then 1, 2, 3 across and then put a blob. You can do it again. Go 2 up and then 3 across and then put a blob. I've run out of space, so I'll just go back to there. 2 up and then 3 across and then put a blob. And then just connect those blobs with a straight line. Connect those blobs with a straight line. Okay, slightly missed. Okay, hit. And so there's my sketch of that line. So I use the gradient and the y-intercept to sketch that line. This time I'm not going to use the gradient and the y-intercept. I'm going to use, I mean I can do, it's in that form where you can use the, I'll use it. I'll use the y-intercept is 4 and the gradient is minus 8 over 1. Minus 8 up, 1 across. So minus 8 up, 1 across is there, and then connect them together with a straight line. Oh, it's going to be a very steep line downhill. Okay, so there's my line. I didn't even quite get it steep enough. So there's my line. Okay, in this form, I don't want to have to bother to make y the subject. So for this, I'm going to say, well, we'll switch to the method where we find the root and the y-intercept. And again, it's going to be quite easy to find the root. To find the root, we just put y equal to 0, which is just going to make that, put x equal to 0. And sorry, to find the root, we put y equal to 0. And so that put y equal to 0. And so that's going to give us the root is at minus 5. The root is at minus 5. Root is at minus 5. And then if I want to find the y-intercept, you just put x is 0. And so that's going to give us y is 4. And so it's going to give us y is 4. And so we can connect those 2 points together with a straight line like that. And so there's our sketch of that equation there. Okay, so easy, 2-intercept form. Again, to find the root, I'm going to scratch out this. And so the root will be at 7. So the root will be at 7. And to find the y-intercept, I'll scratch out that. And so that's going to be at 3. That's going to be at 3. Connect them together with a straight line. Oops, I'm going to miss again. Yeah, got it. Okay, so we're going to move on to something slightly more intriguing. I've made this a really easy question where you can almost read the answer from the diagram. But don't let that fool you, because the questions in the homework, the numbers won't come out as whole numbers. They'll be like, you know, 4 and 3/8 or something like that. And you might think it's 4.5 and it won't be 4.5. And so you do need to use the algebra to work it out. Here I might just skip some of the algebra because it's going to be so obvious. A is 1, 2. 1, 2. B is 3, 6. B is 3, 6. I want the perpendicular bisector of AB. What does that even mean? Okay, so I want the perpendicular bisector. Okay, well, it's going to have to go through the midpoint. It's going to have to go through a midpoint. That's what the word bisector means. It's going to have to go through the midpoint. And in my case, I can just see my midpoint and read it from my diagram. Midpoint is 2, 4. It would be dangerous in all situations to read it from the diagram, especially if the diagram is a sketch. And most of the time it will be a sketch. You won't have a grid. And, you know, even if you have got a grid, it might not be exactly on that point. It might look like it is, but it might not be. Anyway, find the midpoint. So it's called the perpendicular bisector. It means goes through a bit. Find the gradient perpendicular. because it's a perpendicular bisector, it's got to be 90 degrees. Perpendicular means 90 degrees. It's got to be 90 degrees to this dotted line here. So our line is going to look like this. It's going to be 90 degrees to that line there. So it's going to be sort of like that. Going to be like that. And we know the gradient of this line. Well, we don't, but again, it's a very easy one. So I'm just going to tell you the gradient of this is 2. But you know how to find it. You subtract the coordinates and then reverse divide. And so we know that the negative reciprocal will give us the gradient of this. The gradient of this is -1/2. And so now we want the equation of the blue line. We know a point on the line and we know its gradient. We can use y minus y1, y minus 4 equals, the gradient is -1/2, x minus 2. I'll multiply through by 2 because we don't want fractions. So that's going to give us 2y minus 8 equals 2 minus x. And then that's going to give you x plus 2y equals 10. And so there's our equation. Same sort of thing again, find the perpendicular. It's going to be an easy question again, so we're going to be able to do it with very little effort. C is 1,4, B is 3,6. The line connecting them would be this line here, so the perpendicular bisector would go through the midpoint and it would be at 90 degrees, so it would look like that. I can see the midpoint from my diagram because it's just such an easy question. The midpoint is 2,5, and the gradient of this line I can tell again from my diagram because it's such an easy one. The gradient is 1, so the negative reciprocal will mean the gradient of this is -1, and then y minus 5 equals -1, x minus 2. And so y minus 5 equals 2 minus x, and x plus y equals 7 is my equation. Okay, we talked about altitudes and medians already, and now it's showing us a triangle and it's asking us to find the altitude through R. So we know that the altitude through R, it has to go through R and then it has to be perpendicular to the other side. So it's got to be perpendicular to the other side. So it's got to look like this. Okay, how do we find its equation? Well, to find its equation, we need to know two things on it. We already know it goes through the point R, and we know the coordinates of R. R is 5,1. So that's one thing already. We need another thing. Well, it's going to be perpendicular to QP. That's the rule. The altitude through R has to be perpendicular to the opposite side. And we can find the gradient of QP because we know the coordinates. So Q is 4, -1, and P is, Q is 2, 3, and P is 4, -1. And we want to find the gradient, so we subtract, so that's going to be 4, that's going to be -2, and so the gradient is -2. So this line has got a gradient of -2. This is going to be the perpendicular gradient, the negative reciprocal, so this is going to have a gradient of 1/2. And so this line is y minus 1 equals 1/2 x minus 5, or 2y minus 2 equals x minus 5, or x minus 2y equals 3. X minus 2y equals 3 is our equation of this line. Okay, so there's the altitude through R. Now it wants us to find the median through R. So the median through R is going to go through R, and it's going to go through the middle of QP. Oh, well okay, that was an easy one. Because my diagram was very good, I was able to see it straight away, and because it was a very easy question anyway. So we know that this is a horizontal line, so it's the horizontal line y equals 1. Finding the area of a triangle. If a triangle is right angled or is isosceles, or if one side is vertical or horizontal, then we can just use area as half base times perpendicular height. So we want to find the area of this triangle here, and let's just draw in the sides. So we've got a side here, a side here, and a side here, and we're told the coordinates of the points. So the points are P is -3, 1, P is -3, 1, Q is 3, 3, and R is -3, 8. One side is vertical, then it's going to be easy. Make that the base of your triangle. Tip your head onto the side and make that the base of your triangle. So this is going to be the base, which is going to make this the height. This is going to be the perpendicular height here. So that's going to be the height. And we can see that's from -3 to 3. So the height is going to be 6. And the base is from 1 up to 8. So the base is going to be 7. So the area is going to be a half times the base, which is 7, times the perpendicular height, which is 6, which is 21 units squared. That was particularly easy because one side was vertical. So right angled triangles, or if one side is vertical or horizontal, or isosceles triangles, are going to be very easy to find the area. Okay, this triangle is not right angled, and there's no horizontal or vertical side, so how are we going to find the area of this? This is the triangle we had from before, and we did find the altitude before. We found the altitude before was let's make it a bit thicker, and so the altitude was like this line here. And so we found the equation of the altitude before. We just did that over here. There was the altitude. It was x minus 2y equals 3. So x minus 2y equals 3. That's going to help us. X minus 2y equals 3. That's going to help us because if we can find this point here, let's call it x, then this can be the height of the triangle. This can be the height of the triangle. And then that will be the base of the triangle. Okay, but we'd need to find the coordinates of x first. And the way we'd find the coordinates of x is we'd use simultaneous equations. We'd find when this line here meets this line here. But we don't know the equation of QP. Okay, well, you know what? We can find the equation of QP. I can see already from the diagram quite easily that it's got a gradient of -1, got -2, gradient is -2. And so I can use y minus, I'll use Q, y minus 3 equals -2, x minus 2, y minus 3 equals 4 minus 2x, 2x plus y equals 7. And then I'm going to use simultaneous equations with the other equation, which was x minus 2y equals 3. Oh, I need to eliminate something. So I'm going to double the top equation so that I can eliminate the y's. So I'm going to double the top equation. So that's going to become a 4, that's going to become a 2, and that's going to become a 14. Okay, and then I'm going to add the two equations together. Add the two equations together. So that's going to give me 5x equals, and then 17. So x is 17 over 5, which is 3 and 2/5. 3 and 2/5, or 17 over 5. And then let's just substitute that back into this equation here to find the y coordinate. So that's going to give me 3 and 2/5 minus 2y equals 3. 2/5 equals 2y. Y equals 1/5. Okay, so I found the point where they meet. The point where they meet, x, is 1/5 and 17 over 5. 17 over 5. Okay, and then we said we were going to use that to work out the height. So we're going to use that to work out the height. So the height is the distance from x to q, x to r. So r is 5 comma 1, and x is 1/5 and 17/5. So if I want to find that, I need to subtract them. So 1 minus 17/5, so that's minus 12/5, and 5 minus 1/5, so that's going to be 4 1/5. So, oh, hold on, whoops, error, put my coordinates in the wrong way around. Careless error. 17/5 and 1/5. Oh, okay, I need to swap them here as well. So 17/5 and 1/5. And so if I subtract them, that's going to give me 4/5. So that's going to give me 4/5. And that's going to give me 8/5. And then I'm going to square them and add them, and that's going to equal to the length of rx squared, just like we did before. So that's 64/25 plus 16/25 equals the length of rx all squared. The length of rx all squared equals 80/25, and so the length of rx is going to equal square root of 80. 80 is 16 times 5, so that's going to give me 4√5/5. Okay, so we've worked out this length here is 4√5/5. So 4√5/5 is that length there. But this is going to be our base. Over here is going to be our base. This is going to be our base. So I need to work out that length as well. Oh my god. Okay. So the base is going to be from Q to P. So let's work out that. Q was 2, 3. Q was 2, 3. And P is 4, -1. And then we want to work out that length. So we subtract them again. So that's 4. And that's -2. And then square them and add them. And that's equal to the length of QP squared. So that's going to be 20 square rooted. So 2√5 is going to be the length of QP all squared. And so we're going to do a half times the base times the height. So a half times the base, which is 2√5, times the height, which is 4√5/5. The half and the 2 cancel out. The √5 and the √5 give you 5, which cancels out with the 5 at the bottom, so it gives us 4 units squared. Over here it's saying, are there any alternative methods for finding this area? I think there are, and to be honest, I think the alternatives are simpler than that. I mean, you know, sometimes an exam question will direct you along that route because it will force you to find that line, and it will force you to find where they intersect, and then it will say find the area. So it's sort of forced your hand largely. But if I was working out the area of this triangle from scratch, I would be more inclined to simply box it. Like that. And then I can say that that box has got an area of, well, it's 4 times 3. So the box has got an area of 12. So the box has got an area of 12. Let's just shade that in. And let's just say the yellow area is 12. So the yellow box is 12. So the yellow box is 12. Okay. Now what I'm going to start doing is I'm going to work out these triangles. And there's 3 of them, but they're just, you know, right angled triangles. So I can just already use half base times perpendicular height. Here the base is going to be 3. And the height is going to be 2. So that one there, that triangle there, is going to be 3. And I'm going to subtract it. Okay. Now I'm going to do this triangle here. And that triangle there, half base times height, is going to be 4. So that triangle there is going to be 4. And I'm going to subtract that as well. And subtract that one. And then the last triangle is going to be 1. I can see the area, I can see the base, I can see the height. 10. The last triangle is going to be this triangle here. And that's going to be 1. And so that gives me 8. 12 minus 8 is 4. Much quicker method. Doesn't rub out very well, does it? Okay, and so it leaves me with the area that I wanted. There is even a third method that you could use, which is, let's say for instance, you work out the area of, let's just rub that out. You work out, no, I didn't want to clone it, I wanted to delete it. Okay. What you do is you work out the gradient of this line. You work out the gradient of this line. You work out the gradient of this line. And then you remember you can use the gradients to work out the angles. So you work out the 2 angles, subtract them, and then that will give you that angle theta. And then you can call this length here B and this length here A. And because you've got the angle, you can use a half AB sine theta or sine C. And so that's the alternative method. Again, it depends on what you've already worked out as to which of those methods you'd use. Rhombuses and parallelograms, they both have parallel sides, but for a rhombus all the lengths are the same. So a rhombus is really like a square, except it's a topsy-turvy square. It's a square that somebody's kicked and they've bent it. Whereas a parallelogram is a rectangle that somebody's kicked and bent. The lengths are not all the same as each other. The diagonals are marking the center. So if you draw the diagonals, they do mark sort of the center. So the diagonals mark the center. But what is more interesting is that the diagonals of a rhombus meet at 90 degrees. They don't on a parallelogram, but they do on a rhombus. They meet at 90 degrees. So that can be useful sometimes. Okay, we have a parallelogram. It's got vertices 2, 8. So here's one of the vertices, 2, 8. I'll just go back to a solid line. Oh, I have gone back to a solid line. I didn't mean to do that. Okay. And I'll make it a bit thinner. So there's one of the vertices. And then here's the other vertex. Okay. And then it says draw the parallelogram. Well, it doesn't say draw the parallelogram. It says find the coordinates of the third vertex. And so first of all, I need to draw the parallelogram because only then could I work out the coordinates of the third vertex. And the way I draw the parallelogram is I would clone this and put it onto here. And I would clone this. Now mine is a particularly simple one. My diagram is really good. So I can see immediately that the third vertex is 6, 2. So D is 6, 2. I can see that immediately from my diagram. D is 6, 2. But if I was doing it otherwise, I might work out this vector here. I might work out that vector there, and I might say that this point here is 2, 8, and this point here is 4, 6. And so this vector from here to here, how many do you have to go along x? -2. How many do you have to go along y? 2. And so that's going to match this vector here. They're going to be the same vector. So that vector there is going to be -2 and 2. And I know that that's 8, 0. So starting from 8, 0 and minusing 2 will give me 6. And starting from 0 and adding 2 will give me 2. So I could read mine from my diagram, but even if I couldn't, it wouldn't be hard to work out. Find the reflection of the point P31. So here's our point P31. Here's our point P31 in this line here. Now I'm going to add that line to my diagram, and I know that the y-intercept of the line is 2, and I know the gradient is 1 up, 2 across. So I'm going to start from 2, and I'm going to go 1 up and 2 across, and so that's going to be my line. Okay, and that's supposed to be a mirror line. So that's supposed to be a mirror line, and so I want to find the reflection of P in that mirror. So let's say P is somewhere over here. So let's say P is somewhere over here, P dash. You know the rule from GCSE physics, which is it's going to be the same distance behind the mirror as P was in front, and it's going to be along a normal. A normal is like a perpendicular. Oh, whoops. I wanted to draw a line. So it's going to be along a perpendicular. It's going to be along a normal. So that's supposed to be 90 degrees. Not sure how good my 90 degrees is, but it's supposed to be at 90 degrees here. Okay, and then it says find P dashed. I don't know why it looks like P exclamation mark. It's supposed to be P dashed. Okay, here's what I'm going to do. I know the gradient of this line is a half. So that tells me the gradient of this line is the negative reciprocal, -2. So I can find the equation of this line. So y minus 1 equals -2 x minus 3. And so y minus 1 equals 6 minus 2x. 2x plus y equals 7. Now I can do simultaneous equations and find this point where they meet. I can do simultaneous equations and find this point here where they meet. And so this time I'm going to use substitution. I'm just going to substitute that into y. So 2x plus a half x plus 2 equals 7. So 2x plus y equals 7. So 2 and a half x equals 5. So x equals 2. X equals 2. Put x's 2 back into this equation, and so that's going to give you 3. So this point here is supposed to be 2, 3. My diagram's missed a little bit. Okay, never mind. Okay, now I can use vectors again. I can say that that vector has got to match that vector because it's got to be the same distance along. And so I can say, well, I know what that vector is. It is going from 3 to 2 is -1 along the x-axis, and it's 2 along the y-axis. So I know this one's got to be -1, 2. And so starting from 2 and subtracting 1 is going to give me 1. And starting from 3 and adding 2 is going to give me 5. And so there's my point. Okay. Harder question. So this is a harder question now. And so for this harder question, maybe a diagram is going to be appropriate. Line 1 has equation 11 minus 2x. Line 2 is perpendicular to line 1. Lines 1 and line 2 cross the line x equals 5 at A and B respectively. The length of AB is 7.5 units. The lines meet at C. Find the area of a triangle ABC. Okay, so it's convoluted. That's what I said to you. The questions are going to get convoluted, you know, as we get into A-level maths. That's a sort of typical A-level maths question. Let's start off with the first line, which is 11 minus 2x. I might just drop this down a little bit more to give me a little bit more space, because that 11 minus 2x, well, that's got a y coordinate of 11. So anyway, I'm not going to mark it properly. I'm just going to say, look, that's 11, and 11 minus 2x is going to be just this line here. So let's put it in blue, and it's going to have a gradient of -2. So that's going to be like that. Okay, so that line is y equals 11 minus 2x. Y equals 11 minus 2x. Okay. You know, I know what that root is going to be, because I can just put in y is 0, and so that will give me 5.5. 5.5. Not that I need it, but just add it to my diagram. Why not? Line 2 is perpendicular to line 1. So, I mean, I don't really know where to draw line 2. It's perpendicular, so let's just say, you know, it's like that. But I mean, 90 degrees. Is that 90 degrees? Okay. but I don't know where it is. I mean, it could be anywhere. It could be here, it could be here, it could be here, it could be here. I'll just put it here for the time being and we'll see where it ends up. Lines 1 and 2 cross the line x equals 5. Well, x equals 5 is just a vertical line. So x equals 5 is just this vertical line here. Well, it will be very close to 5.5, so it'll be there. I might just move it a little bit away because otherwise it's going to end up a bit squashed up in that region there. So, okay, so there's the line x equals 5, and the lines cross at A and B respectively. So let's call that A and let's call that B. Okay, the lines cross at A and B respectively, and then it says A to B is 7.5 units. So this distance here is 7.5 units. Okay. The lines meet at C. The lines meet at C. Find the area of triangle ABC. Okay, now it's all starting to make sense. The diagram has helped me enormously. They're perpendicular, so I'll just put in my 90 degrees here, my foot of my perpendicular. And let's get cracking with working out. I can easily work out A because it's basically where the x coordinate is 5 on this line here, on the blue line, where the x coordinate is 5. So let's just go to color. That's just going to be 5. So that's where the x coordinate is 5. So I'm just going to put in x is 5 into that equation there. So y equals 11 minus 2 lots of 5, which is just going to be 1. So this point here is 5, 1 is A. And then this point here has got to have a y coordinate 7.5 units higher. So that's going to be 5, 8.5. Okay. And now I know this gradient is minus 2. I know this gradient is minus 2, and this is perpendicular, so it's going to have a gradient of 1/2. And then I now know a point on this line, and I know its gradient, so I can just do y minus 8.5 equals 1/2 x minus 5, and 2y minus 17 equals x minus 5. And then 2y minus x, oh really I should do it the other way around, x minus 2y equals minus 12. Okay, so there's this equation, x minus 2y equals minus 12. Okay, so done that. I need to find where they meet. I need to find where they meet because the lines meet at C. It says find the area of the triangle. If I want to find the area of a triangle, I need to find where C is. Okay, so let's just do simultaneous equations between this equation here and this equation here to find where they meet. So we've got, I'm just going to substitute this y equation here into here. So minus 12 equals x minus 2. And then I'm going to substitute in this equation 11 minus 2x. So minus 12 equals x minus 22 plus 4x. And so 5x equals 10. And so x is 2. Okay, so x is 2. X is 2. 2 comma, and then the y coordinate I can just put 2 back into here, so that's going to give me 11 minus 4, which is 7. 2 comma 7 is that coordinate there. Now I want to find the area of this triangle, but I remember the rule. Yes, sure, it's a right angled triangle, and sure I could call this the base. I could call this the base, and I could call this the height, but I'm not going to do that. I've got an even easier method, which is if one side is vertical, then call that the base. So this is going to be my base, and I already know the base is 7.5, and then this is going to be my height. And again, I can just read that. I know that this has got an x-coordinate of 2, and I know that this has got an x-coordinate of 5, so that's just 3. And so it's a half times the base, which is 3, times the height, which is 15 over 2. 15 over 2. And so that gives us 45 over 4, or 11.25 units squared. Okay, last question. Again, it's one of the harder questions. Line 1 has equation 2x plus 3y equals 6. Line 2 has the same root as line 1, but line 2 is perpendicular to line 1. Okay, well, let's start our drawing. So, let's put some axes. Okay, let's try and move that one down a bit. Okay, so 2x plus 3y equals 6. Well, that makes it very easy. I can tell you that the root is going to be at 3. So 1, 2, 3 is the root. And the y-intercept, whoops, didn't mean to rub it out. The y-intercept is going to be at 2. The y-intercept is going to be at 2. Okay, so let's draw that line. Okay, missed again. Missed and got the angle slightly wrong. Okay. Okay, so there's my first line. Okay, and I can see the root of that line is at 3. Line 2 has the same root. Oh, so it goes through this point here. It goes through this point here. But it's perpendicular to line 1, so that makes this line 2. It's perpendicular to line 1. Okay, so there's line 2. Let's put my perpendicular in. Let's draw the foot of my perpendicular here. Now, I know that line 1 has a gradient of, blue. Has a gradient of minus 2 over 3. So gradient is minus 2 over 3. So that tells me instantly that this perpendicular gradient is going to be the negative reciprocal. It's going to be 3 over 2. And so I could easily find this equation out. Y minus y1 equals 3 over 2 x minus x1. And so it gives me 2y equals 3x minus 9. And 9 equals 3x minus 2y. So that's this equation here. 9 equals 3x minus 2y. Okay. Q is a point along line 2 such that PQR is area. Okay, where's P? The lines meet at P. Okay, so that's P. So that's P. And line 1 has an y-intercept at R, so that's R. And then Q is a point along line 2. So Q is a point along line 2. It's not on line 2 yet, but I'm going to put it on line 2. And I don't know where it is. It's somewhere here along line 2. I don't know where. I'm just going to put it here for the time being. Such that area of triangle PQR. Okay, well, PQR would just be that triangle there, and they want it to have an area. It's a right angle triangle, so we can do area as half base times perpendicular height, and the blue line would be, say, the base, and then the purple line would be, say, the height. And the area is 26. So the area of this area is 26. And they want to find the possible coordinates of Q. Now, the reason why they're saying possible coordinates of Q is I could move Q down to the opposite end of the line. So I could move Q. Let's just extend this line a bit. I could move Q down to this side here. No. Oh, Q separated itself. Okay, I could move Q down here, right down there somewhere, and it would still give me the same sort of triangle. It would give me the same area. I'm not going to bother doing that. You can do the second one yourself quite easily. Okay, right, so how are we going to do this? Well, first thing I'm going to do is say area is half base times height, and so I know that I want to work out this length here. So and that's the coordinates are r is 0, 2, and p is 3, 0, and then subtract them. So 2 minus 3, square them, add them, and square root it is the length of rp squared. So rp is 13 square rooted, root 13. So this length here is root 13, and that's going to be my base. Okay, so my base is root 13. And then I can say area equals half base times perpendicular height. So area equals a half times base times height. 26 equals a half times root 13 times the perpendicular height. I don't know the height, I'll just call it h. Okay, and so I'm going to work out h by dividing both sides by root 13 and timesing both sides by 2. So 2 times 26 over root 13 equals h. I'll multiply the top and bottom by root 13. Whoops. I'll multiply the top and bottom by root 13 to do the surdy thing. Root 13, root 13. That's going to give me 13. That's going to cancel with that. That's going to give me a 2, and that's going to give me 4 root 13. So the height here is going to be 4 root 13. So this height is going to be 4 root 13. Okay, I'm going to use that to work out Q. But the way I'm going to use it to work out Q is kind of sneaky. Because if I try and use it by doing this, Q to P equals root 13. So Q is x comma y, and P is 0, 3 comma 0. And then Q to P, x minus 3 squared plus y squared equals 13 squared equals 4 root 13 square rooted. If I try doing that and then squaring both sides, I'm going to end up with a big complicated, you know, messy quadratic-y kind of thing. I mean, it will work, but I'm going to suggest an alternative. I'm going to suggest what we do is we just move. We know that this line has a gradient of 3 over 2. So I'm just going to do a simple vector. I'm going to do 2 along the x-axis and 3 along the y-axis. Because the gradient tells me 3 up, 2 across, which is 2 along the x-axis, 3 along the y. And I'm just going to go to this point here. I'm not going to go to Q. I'm just going to go to this point here. I'm going to call this, I don't know, Q dashed. I don't know why I called it Q dashed. And it's the vector from here to here is 2 along the x-axis, 3 along the y-axis. And I'm going to say, what's the length of P to Q dashed? And you're going to say, it's easy. It's just that squared plus that squared square rooted. So it's root 13. And then I'm going to say, but I don't want it to be root 13. I want it to be 4 root 13. So I'm going to multiply it by 4, times it by 4. And then it's going to be P to Q, not P to Q dash. And it's going to be 4 root 13. And instead of being a vector of 2, 3, it's going to times by 4. And so it's going to be 8, 12. And so we now know that this vector from here to here, let's go thicker. This vector from here to here is 8, 12. And so we're starting from an x coordinate of 3. We're adding 8, so that's 11. And we're starting from a y coordinate of 0, and we're adding 12, so that's 12. Okay, so that's what you'll find in the homework. Okay, there's your next challenge question. So remember, if you can do the challenge question and you can answer it and you can give it to me by next week, then you get a get out of homework free card. Okay, so this is the homework, and on exercise 5.4, I've said if you can do it with no mistakes. So you know what you'll find? 5.1, 5.2 and 5.3 are like the mechanical bits that we were doing earlier on. And 5.4 is much more like these questions here, like this one, and maybe this one, and maybe this one here. These kind of questions. They'll be more like those kind of questions. So if you can do 5.4, you start doing 5.4 and you think, oh, I can do these. I'm making no mistakes whatsoever. Maybe one mistake maximum, one question wrong, or 2 halves of a question wrong. Then you don't have to do the other exercises and you can save yourself a whole bunch of time. But if you're flopping 5.4, even getting 2 or 3 wrong, then you need to do the earlier exercises as well. Okay.